Welcome back as we continue our wonderful journey in core mathematics. My name is Nanaya Wedu, and you can call me Say Nana. Remember to like, share, comment, and click on the notification bell as well as subscribe to my YouTube channel so that you can get all videos on time. In our previous lesson, we have considered operations on vectors. We have looked at how we can add vectors. And in this lesson, we want to look at operations on vectors, where we'll consider how we can multiply a vector by a scale factor. Now, let's consider what it means when we are asked to multiply a vector by a scale factor. So basically, when we are asked to multiply a vector by a scale factor, let's assume that we have our vector A, as has been indicated here, and A has coordinates with the x coordinate as A and the y part as B, right? And then we are multiplying it by the factor x. So this implies that we have our A multiplied by x, and we see that it's also equal to our x multiplied by A, because we know that when it comes to multiplication in terms of vectors, it is also commutative. It doesn't matter which way we put our A, which is our vector, and then our scale factor. Although we can begin with our scale factor and then have our vector, right? So that implies that this should give us, we have our A multiplied by our x, and then we have our B multiplied by our x. So the whole idea is that multiply the x by the top part, and then multiply the x by the down part, right? So multiply the x by the top part of the vector, then multiply by the down part of the vector. So let's consider an example. So in this example, we said if vector p, and they've given us a vector for p, q, and then that of r, and we have to perform some operations where we would add as well as multiply it by a particular scale factor that has been given to us. So let's look at how we can solve this question. So the vectors that have been given to us includes vector p, where we have our vector p to be equal to -4 and 3, and then we have our vector q to be equal to 2, -3, and then we have our r to be equal to 10 and 8. And in the question I, we are asked to find 2p plus half r plus q. So let's perform that operation. So basically 2 multiplied by our p, so we have 2 multiplied by the vector -4 and then 3, right? Then we have the addition, so we have half multiplied by the vector 10 and 8, because 10 and 8 represent r. And then we also have plus q, and we know our q is 2, -3. So that implies that our 2p plus half r plus q should be equal to 2 multiply the top part, that will give us -8, 2 times -4. Then 2 multiply 3, that should give us 6, right? Then plus the half will multiply the 10, so it means that 2 divide 10, 2 go here 1, 2 go into 10, the 5, right? So here becomes 5. Then the same half will multiply the down one here, which is the 8. So 2 go here 1, 2 go here 4. So it means this part to be 4, right? And then plus 2 and then -3. So that implies that our 2p plus half r plus q should be equal to, right? So we now come and perform the addition. So -8 plus 5 should give us -3, and then plus 2 should give us -1. And then 6 plus 4 should give us 10. 10 minus 3 should give us 7. So it means that our 2p plus half r plus q should be equal to -1 and 7. Now let's consider the II. So in the II, we are given 4 q plus p, right? So 4q plus p. So it implies that we have our 4. We know that our q is 2, negative 3, right? And then we have plus our p, which is 4, negative 4, and then 3 from our question, right? So this implies that we can write it this way as well. So 4q plus p should be equal to, we can have our 4 multiplied by 2, then 4 multiplied by negative 3. So you can perform it this way, step by step, and then you have plus negative 4, and then 3, right? So 4 times 2 now gives us 8, and then 4 times minus 3 gives us negative 12. Then we have plus negative 4, and then 3. So our 4q plus p should be equal to 8 plus minus 4 should give us 4. And then negative 12 plus 3 should give us negative 9, right? So that is our II, 4q plus p. Now let's perform our last one where we are asked to find 1 over 3. So we are asked to find 1 over 3 q plus half r plus p. So that is I. So in this case, we know that 1 over 3 q will be 1 over 3. Our q is 2, and then negative 3, right? And then plus half multiplied by r is 10 and 8. And then plus our p, right? Where our p should be negative 4 and 3, right? So that implies that we 1 over 3 will multiply the top. So we have 1 over 3 multiplied by 2, then 1 over 3 multiplied by negative 3, right? And then we also have plus 1 over 2 multiplied by 10, and then 1 over 2 multiplied by 8. And then our last one, which is our p, stands alone, so minus 4 and then 3. So we would have to go through this. We cannot cancel anything here, so we have 2 over 3 at the top, and then the down one, 3 can cancel this, so we have negative 1. Then we have plus 2 go here, 1, 2 go here, 5, so we have 5. 2 go here, 1, 2 go here, 4, so we have 5 and 4. And then we have plus negative 4 and then 3, right? So now we have the addition to perform. So it means that when we take the y coordinates, we can be able to find that one easily. So basically for the y coordinates, negative 1 plus 4 should give us 3, and then 3 plus 3 should give us 6. And then for the x coordinates, it means that we need to find LCM, and our LCM is 3, right? So 3 will go into itself 1. 1 multiplied by 2 should give us 2, right? 3 will go into 1, right? Because we assume that this is 5 over 1. The 5 part is 5 over 1. We assume that the negative 4 is negative 4 over 1, right? Any number can be written as a fraction when we divide it by 1. So it means that 3 will go into the 1 3 times. Then 3 times 5 should give us 15. So 15 here. And then 3 will go into the 1 3 times. 3 times negative 4 should give us negative 12. So that will mean that our 2 plus 15 giving us 17. And then minus 12 should give us 14. Right? So 2 plus 15 should give us 17. 17 minus 12 should give us 5. Okay, so you should get 5 rather. So it means that our top part should be 5 over 3, and then our down part should be 6. So this means that our 1 over 3 q plus half r plus p should be 5 over 3 at the top, and then 6 down. So basically in this lesson, we have gone through the process of multiplying a vector by a scale factor. And we realize that when we are multiplying a vector by a scale factor, we multiply the scale factor by the x component as well as the y component. In our next lesson, we want to consider trigonometry. Remember to share this video, like the video, and subscribe to my YouTube channel. See you in the next lesson.